Hey, welcome to Models and Agents, episode 28. It's April 9th, 2026. Your daily briefing on the AI models and agents that are changing everything. And no, not those kinds of models and agents. Let's get into it. Meta's Muse Spark and a production-grade compiler as a service approach for agents headline a day heavy on practical agent infrastructure. What you need to know is that today mixes fresh model drops with genuinely useful agent tooling. The real signal is the growing realization that giving agents structured compiler understanding of code dramatically beats raw text retrieval augmented generation. Several new RxIV papers on accountable, shielded, and governed multi-agent systems also show the research community is finally moving past toy demos toward production safety. So let's start with the top story that has developers talking. A detailed Reddit discussion shows what happens when you wire Roslyn-style compiler as a service tooling into AI agents working on large Unity codebases exceeding 400,000 lines of code. The author demonstrates that the compiler approach surfaces only 13 real dependencies in a monolith. Meanwhile, traditional grep had flagged 100 apparent dependencies, most of them false positives. This is a massive leap because it gives agents precise value tracking, dead code detection, and mathematical precision checks. Instead of raw text access, agents now get IDE-level semantic understanding of the codebase. Microsoft enabled this capability with Roslyn over a decade ago, but only now are AI workflows fully leveraging it. The compounding benefit for agents is described as substantial. The poster estimates that only 1 to 5% of practitioners currently use this kind of tooling. Several similar compiler-backed agent projects appeared in the comments. If you maintain large code bases or build coding agents, this pattern is worth testing immediately. Moving on to model updates, Meta released Muse Spark, its latest foundation model. While full technical details are still emerging, the announcement positions it as a significant addition to the current wave of multimodal and agent-capable models. Early coverage suggests it targets creative and generative tasks that could integrate well with agent workflows. I am curious to see how it performs once more people get access. In other model news, a new analysis compares sigmoid versus ReLU activation functions. It quantifies how ReLU's destruction of distance from boundary information creates measurable inference costs compared to sigmoid in geometric reasoning tasks. The work frames neural networks as spatial transformation systems. It shows that preserving how far a point lies from decision boundaries matters for deeper layers. Practitioners working on geometric or scientific models should revisit their activation choices. This is one of those subtle but important findings that can quietly improve performance. Now let us talk about the agent and tool developments that stood out today. Developers are increasingly wiring Roslyn-style compilers directly into agent loops. This gives agents semantic understanding of large code bases instead of brittle grep-style search. Real-world gains include accurate dependency graphs, live value tracing, and dead code elimination that pure large language model reasoning misses. The quality improvement compounds as code bases grow past a few 100,000 lines. Microsoft's FARA team open-sourced the Universal Verifier along with CUA Verifier Bench. The benchmark is a dataset of computer use agent trajectories with process and outcome labels. Their system uses non-overlapping rubrics, separate process and outcome rewards, cascading error-free scoring, and divide-and-conquer screenshot attention. It matches human agreement rates and slashes false positives versus previous baselines like Web Voyager and WebJudge. This is a big step toward making computer use agents more reliable in production. We also saw the release of AgentOpt version 0.1. It is a framework-agnostic Python package that optimizes model assignment across multi-step agent pipelines. The package implements 8 search algorithms, including ARM elimination and Bayesian optimization. These algorithms navigate the combinatorial explosion of model choices. On 4 benchmarks, it recovers near-optimal accuracy while cutting evaluation budget between 24 and 67%. The cost gap between best and worst model combinations reached 13 to 32 times in their tests. This makes systematic model assignment suddenly practical. Shifting to practical and community highlights, the TurboQuant Pro team shipped a 10-second command line tool called AutoTune. It samples embeddings from PostgreSQL with pgvector, sweeps 12 PCA plus TurboQuant configurations, and recommends the Pareto optimal compression meeting your recall target. On a 194,000 vector BGEM3 production corpus, it delivered 20.9 times compression at 0.991 cosine similarity while maintaining 96% recall at 10. That shrank 758 megabytes down to 36 megabytes. You can install it with pip install turboquant-pro bracket pogvector and run the autotune command. If you run a vector database, this is one of the highest leverage tools released this week. There is also an excellent new tutorial on building advanced document intelligence pipelines. It walks through installing Lang extract, configuring OpenAI models, creating reusable structured extraction pipelines, and adding interactive visualizations. The guide shows how to turn unstructured documents into machine-readable data at scale. It is an outstanding starting point if you need production-grade document intelligence beyond basic retrieval augmented generation. Finally, the community is excited about SurfSense. It is an open-source, privacy-first alternative to Notebook LM that removes all source and notebook limits. It supports any large language model, image, text-to-speech, and speech-to-text model. The tool integrates 25-plus external data sources, offers real-time multiplayer, and includes a desktop app with quick and extreme assist modes. If you have already hit Google's constraints, this looks like a drop-in upgrade for research or team knowledge work. Now, for things you should actually try this week, run TurboQuant Pro AutoTune against your PG vector table with min recall 0.95. You will likely discover 15 to 80 times compression options tuned to your actual data distribution in under 15 seconds. Next, wire a Roslyn or equivalent language server instance into your coding agent loop and give it a dependency query tool. Compare the hallucination rate and plan quality against your current retrieval augmented generation baseline. Test the open source universal verifier from Microsoft on your computer use agent trajectories. The process versus outcome reward split alone usually surfaces bugs that pure outcome checking misses. Spin up SurfSense if you have hit Notebook LM source or notebook limits. The unlimited sources plus any large language model backend makes it a genuine upgrade. Finally, experiment with AgentOpt's ARM elimination search on your multi-model agent pipeline. The 24 to 67% reduction in evaluation cost makes systematic model assignment suddenly practical. Okay, let us pop the hood on this compiler as a service pattern that keeps coming up. Everyone talks about giving agents code understanding as if it is just better prompting or more context. In practice, wiring a real compiler service into the agent loop is a fundamental architectural shift. It replaces fuzzy text similarity with precise semantic queries and symbolic execution. The core insight is that grep and embedding retrieval operate only on surface tokens. A compiler, by contrast, builds and maintains an accurate graph of types, symbols, control flow, and data dependencies. This graph lets the agent ask questions like which 13 components actually touch this payment handler, or does this variable's value satisfy the precision contract at call site X? Those queries are either impossible or unreliable with pure large language model reasoning. There are engineering trade-offs, of course. You pay an upfront cost to keep the compiler service live and incrementally updated. Incremental analysis like Roslyn style helps here. You must also project compiler objects into a form the large language model can consume without losing fidelity. The payoff is a dramatic reduction in hallucinated dependencies. It also enables symbolic queries that compound across long agent trajectories. The performance numbers shared today are compelling. Dependency counts dropped from 100 false positives down to 13 true ones. Dead code and value flow analysis became trivial instead of guesswork. The quality gain does not disappear at scale. It actually increases as code bases grow past a few 100,000 lines. The gotcha that bites most teams is treating the compiler output as just another text context window. The winning pattern is building small, purpose-built tools on top of the compiler API that the agent can call deterministically. This turns the compiler into a trusted co-pilot rather than more tokens to summarize. So when should you actually reach for this versus the alternative? Adopt compiler as a service the moment your agent codebase exceeds approximately 50,000 lines of code, or when correctness of transformations really matters. For throwaway scripts, plain retrieval augmented generation or simple tool calling is still fine. For production agent coding workflows, the compounding advantage is too large to ignore. On the horizon, expect continued releases of governance and shielding mechanisms for multi-agent systems. Visa and Alchemy's agent payment platforms suggest autonomous commerce agents will move from research prototypes to production pilots in the next 3 to 6 months. Watch for deeper integration between compiler services and agent frameworks. The Unity success story is likely to spawn reusable open-source compiler agent packages. Qualixar OS and similar universal orchestration layers point towards standardized runtimes that let developers mix 10+ large language model providers and 8+ agent frameworks without vendor lock-in. Before we go, tomorrow keep an eye on deeper follow-ups around accountable and shielded multi-agent systems as those RxIV papers get more discussion. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.